So hello everyone. So in this video we will be solving a problem which is pairs violating the BST property. So let's see the problem statement. So problem is saying that we have given a binary tree with n nodes and find the number of pairs violating the BST property. So there is some BST property. So BST has the following properties. These are some properties like every node is greater than the left child and the less than the right child. This is the basic property that every node should be less than the every node of the left child should be less than the root data and the right child should be less than greater than the root data. Every node is greater than the maximum value of in in left its left subtree and less than the minimum value of its right subtree. Okay, the maximum in the left subtree must be less than the minimum of the right subtree. Okay, so this is the important condition, like the maximum of the left subtree must be less than the minimum of the right subtree. मतलब right subtree में जो भी है उससे minimum होना चाहिए वो maximum of the left subtree का. Like if we take this example, like you can see here, if root data is 10, so left is 50, so right should be greater than 50. Actually, right should be greater than 50, and the left subtree of this is 50. This should be less than the right subtree का जो भी मिनिमम एलिमेंट है, पर यहाँ पे 20 है, 20 है, ठीक है, यहाँ पे भी 30 है, ठीक है, और ये 50 है, जो कि कंडीशन हो ही नहीं सकती, थर्ड वाली कंडीशन वायलेटिंग हो जाएगी. तो इस इन दिस कंडीशन व्हाट वी विल डू, वी विल काउंट नंबर ऑफ पेयर्स. So this was the question. So let's see the approach for this. So we know about binary search tree. Like if we find the in order traversal of binary search tree, that should be in sorted order. So in this problem, what we will do is we will find the in order traversal of this binary search tree, and then we will see like how many elements are in sorted order and how many elements are not sorted order. Like if we see this example, so simply in order traversal is easy. Like we need to find L and R order, like left, then node, then right. So if we take this example, like firstly we have to print a left wala data. So 50 is a left data. Then root node, because that we will print the node data. Then root node is 10. Then again we will print the left data, क्योंकि यहाँ पर आएंगे राइट में आएंगे. लेफ्ट प्रिंट कर दिया 50, देन नोड प्रिंट कर दिया 10, देन राइट में जाना पड़ेगा, राइट में जाएंगे तो ये वाला सब ट्री प्राप्त मेरे को मिलेगा. और इस सब ट्री में लेफ्ट वाला कौन सा है 20, देन रूट कितना है 40, देन राइट कितना है 30. सो दिस इज द इन ऑर्डर ट्रावर्सल ऑफ दिस whole binary first tree. So 50, 10, 20, 40, 30. So this should be in sorted order. So if we will take this element 50, so जो कि आगे के एलिमेंट्स हैं जो 50 से बड़े होने चाहिए, बट यू कैन सी हियर आगे कितने एलिमेंट्स पड़े, 10 पड़ा है, 20 पड़ा है, 40 पड़ा है, 30 पड़ा है. ऑल एलिमेंट्स आर लेस देन 50, विच इज वायलेटिंग अवर कंडीशन. सो हाउ मेनी पेयर्स वी कैन जनरेट, लाइक 50 10 का एक पेयर हो सकता है, 50 20 का हो सकता है, 50 40 का हो सकता है, देन 50 30 का हो सकता है, बिकॉज the condition is in order traversal of this binary first tree this should be in sorted order. But if we take this 50, then आगे के एलिमेंट इससे बड़े होने चाहिए, बट यहाँ पर सारे एलिमेंट छोटे हैं. सो हाउ मेनी पेयर्स वी कैन जनरेट, 4 पेयर्स वी कैन जनरेट फ्रॉम 50. देन वी विल सी फ्रॉम 10, आगे के एलिमेंट्स 10 से बड़े होने चाहिए, 20 40 30, सही है कंडीशन. 20 को लेंगे, 20 के आगे वाले एलिमेंट 20 से बड़े होने चाहिए, 30 40, ठीक है कंडीशन परफेक्ट. देन 40 को लेंगे, देन 40 के आगे वाले एलिमेंट 40 से कम होने चाहिए, वो बड़े होने चाहिए सॉरी, बट ये तो 40 से कम है. सो इन दिस कंडीशन वी कैन जनरेट अ पेयर विद 40 30 also. So this will be a one pair, so total number of pairs will be 5. So this is the approach for this problem. So finding out the pairs is very easy. What we can do is we can use brute force solution. Actually brute force solution will also work in this condition. Like you can see constraints are very tight. Like you can see 2 into 10 to power 4. So big of n square will be 4 into 10 to power 8. But in this problem, big of n square will also work because that is in the edge condition. So that will also work because टेस्ट केस ही ऐसे बना है, ठीक है, मैंने अप्लाई करके देख रखा बिग ऑफ एन स्क्वायर वर्क करेगा. सो हाउ वी विल अप्लाई द बिग ऑफ एन स्क्वायर, we will use two loops. For int I equals to 0 to I less than n, then I plus plus, and another loop will go from for int j equals to I plus 1 to j less than n, then j plus plus, and simply we'll check the condition like if ARR of I is greater than ARR of j. In that condition we will increase our count, and finally we will return our count, that will be 5. So that is the brute force solution. So optimal solution is very easy, that we can, if you have done this problem in count inversion. Count inversion is a problem where we find the merge sort technique. We use the merge sort technique. So by using this technique also we can find the, this is the optimal one. So we can find the how many pairs we can generate. Like that the question of that the question is saying that we have given this condition 0 is less than I is less than j, then is less than n, and AR of I should be greater than ARR of j. That question is saying this. But and same in this question we are applying the same technique like AR of AI is greater than AR of j. In that condition we will increase our count. So the question is very similar type of question is this. So if you have done this count inversion, then you can do this easily. Now let's see the code for this. So coding part is very simple, I will say. Like what I will do, I will use the in order traversal of root, and I'll do the merge sort 0 to n minus 1 तक, and finally I will return our answer. So in order traversal देख लेते हैं कैसे करते हैं. Before going in order traversal, we will increase this ARR vector because क्योंकि यूज करेंगे आर का, मैं बताऊंगा कहाँ पे करेंगे, ठीक है. और आंसर को मेरे को रिटर्न करना है, इसलिए आंसर मैंने इनिशियलाइज कर दिया. नाउ वी हैव टू create a in order traversal. So in order traversal is very simple. Like if there is no node, then if a root equals to null, then in this condition we will return our answer. And इन ऑर्डर ट्रेवर्सल का होता क्या है, एल एन आर. सबसे पहले लेफ्ट में जाएंगे तो इन ऑर्डर ऑफ रूट का लेफ्ट, देन नोड ए आर डॉट पुश बैक ऑफ रूट का डेटा. इसलिए मैंने एरे बनाया था वेक्टर, समझे, कि मेरे को नोड प्रिंट करानी है. तो नोड प्रिंट कराने के लिए मेरे को उस नोड को कहाँ एरे में पटकना पड़ेगा. तो एरे डॉट पुश बैक ऑफ रूट का डेटा, देन एल एन एंड फाइनली आर. आर विल बी राइट, इन ऑर्डर ऑफ रूट का राइट. सो दिस इज द इन ऑर्डर फंक्शन. And now we'll see the merge sort function. Merge sort function is very easy. Like you have done this also. If I is greater than or equals to j, in this condition, I'll return our answer, and I'll find out the mid and merge sort I to m and m plus 1 to j. फंक्शन कॉल मार दिया, ठीक है. एक k ले लिया m plus 1 से, और स्टार्ट कहाँ से हो रहा है i तक. एंड दिस कंडीशन आई विल चेक इफ AR of I is less than equals to AR of j, AR of k. So simply I will increase the I, otherwise what I will do, I will increase the k, and I will store the answer equals to m plus I minus 1. So I think you all know about this merge sort function, and finally we will sort this function. So this was the code. If I run this code and see if this will work or not, yeah, it is working perfect. Let's submit this code. Yeah, as you can see here, it is working perfect. So this was a simple code because what we are doing in this problem is we are simply doing the in order traversal. Then we are checking like the binary, the in order traversal of binary search tree should be in sorted order. Like we will see like how many pairs we can see in that in order traversal that are violating this condition. Like they should be in sorted order, but they are not in sorted order. As you can see in this example, 50, 10, 20, 40, 30. So if we take this 50, then आगे के जो भी एलिमेंट्स है वो 50 से बड़े होने चाहिए. बट यू कैन सी हियर ऑल एलिमेंट्स आर लेस देन 50. सो वी विल मेक अ पेयर with 50, and finally we will check that how many pairs we can generate, and finally we will return that pairs. So this was a simple code. If you find this helpful, then please like it, share,